Okay, so we've been discussing parametric curves, and now we're going to get into the calculus of the parametric curves. So one thing that we know we can do is we can take derivatives of functions. And so taking derivatives of parametric functions is not very difficult, okay? The rules are fairly similar to what we've already been doing. To find a derivative for dy dx, there is a parametric formula for this. Now, the requirement is that all three derivatives, that is dy, dx, and dt, must exist, and importantly, dx dt should not be equal to 0. Now it's apparent here from the formula that you see here, dy dx equals dy dt over dx dt, that dx dt cannot be equal to 0 because it's in the denominator. Now, geometrically speaking, what does this dx dt represent? Or I'm sorry, the dy dx. What does it represent geometrically? It represents the slope of the tangent line. Okay, so what we're going to do is we're going to figure out how to take the derivative, but in doing so, we're going to come up with the equation of the tangent line in a few examples. So let's take a look at a couple of examples here. It says, find an equation for the line tangent to the curve at the point defined by the given value of t. So they do give us a t value, and we're going to use that to evaluate the derivative later on to find the slope of the tangent. But let's go ahead and figure out the derivative by using the formula. So let's go ahead and write that out. All right, so let's see what we're looking at here. We know we're looking for dy dx, and we know this is going to be dy dt divided by dx dt. So what does this look like? Well, we're going to have to take the derivative of y. So the derivative of 7 cosine t is going to be negative 7 sine t. So we write negative 7 sine t. Now the derivative of x, which is 7 sine t, is going to be 7 cosine t. So you have 7 cosine t in the denominator. Now you could write this out as a tangent. Sine over cosine is tangent. You can definitely also eliminate the 7's. So I'm going to eliminate the 7's, but I'm going to leave it as sine and cosine. I think it's just a little bit easier to figure out when we're evaluating. So now that we've got that, all right, I again want dy dx, and I want to evaluate it at t equal 3 pi over 4. So what does that look like for me? Well, that's going to be negative sine of 3 pi over 4 over the cosine of 3 pi over 4. All right, now you need knowledge of the unit circle here. So let's figure this out. The sine of 3 pi over 4 is a square root of 2 over 2 from the unit circle. So look that up if you don't know. And of course, we've got that negative sign in front. Now, if you're looking at the cosine of 3 pi over 4, that itself is a negative square root of 2 over 2. All right, so that you have right there. So let me move this over just a bit. What is negative square root of 2 over 2 divided by negative square root of 2 over 2? Well, it's just 1. You're taking a number and you're dividing it by itself. So what we can say here is that our dy dx is equivalent to our slope of our tangent, which is just 1. All right, so we have 1 there. All right, now that we know our slope of the tangent, what I'm going to do is I'm going to take this function x, and I'm going to evaluate it at 3 pi over 4 because I need now a point. I've got a slope. I need a point now. And I'm going to do the same thing for y. Now, the notation here, maybe it's not, conventional what I'm writing, but x is a function of t. So we're going to say that this over here was really like x of t. And this over here was like y of t. All right, so just keep that in mind when you see this. All right, so I'm going to say 7 sine of 3 pi over 4. And over here, I'm going to say 7 cosine of 3 pi over 4. Okay, and we just found those values a minute ago because we were referencing the unit circle. So let's take a look and see what 7 sine 3 pi over 4 is. this is just going to be 7 times the square root of 2 over 2. And this one down here is going to be a negative 7 square root of 2 over 2. And it looks just like that. All right, so to find the equation of the tangent line, let's recall the point slope formula. And I'm sure maybe it's been a while since you've seen this point slope formula, because I think it's been a while since we've talked about equations of tangent lines. So it's y minus y1 equals m times x minus x1. All right, and so let's take a look here. We're going to have y minus, and y1 in this case is going to be this negative 7 square root of 2 over 2. Set it equal to m, which is just 1, times x minus the 7 square root of 2 over 2. Now this minus minus makes for a plus. We move it to the other side, and we subtract. Combine like terms and all that good stuff. So we end up with y equal to, and then the 1 distributed is just itself 1. So we have x, and then minus minus, we know we're going to add them. They're both negative. And you end up with a negative 14 over 2 square root of 2, which is a 7. 14 over 2 is 7, so a negative 7. And you end up with a negative 7 square root of 2. And this right here represents your equation of the tangent line. All right, so let's go ahead and take a look at another example. All right, and in looking at this example, number 2 here, we're going to have x equal to 8t squared minus 5. We're going to have y equal to t squared with a t equal to 1. This one should be a little bit easier for you because there's no trig involved, right? Purely algebraic. So this should be very easy. Let's see here. dy dx. We know it's going to be dy dt over dx dt. So what does that look like? Well, for us, this dx, or dy I should say, is just y prime, which is 2t, over x prime, or dx dt, which is just 16t. All right, when you simplify this, the t's, of course, are going to cross out. And the 2 over 16, rather, is 1 over 8. So this right here is your slope of your tangent. No need really to evaluate the 1. What we're going to do next is evaluate 1 at x and y. We're going to say x of 1 and y of 1, but this is fairly straightforward as well. We plug it into the original functions that they gave us. What do we get? Well, we have 1 squared is 1 times 8, 8 minus 5, 3. And then this is just 1 squared, which is just 1. So we have enough information to point slope this. We're going to say y minus 1 equals 1/8 times x minus 3. We can distribute the 1/8. We get y minus 1 equals 1/8 x minus 3/8. We're going to add 1 to both sides, and we end up with the equation y equal 1 over 8x, and the negative 3/8 plus 1. Well, this 1 is really like 8 out of 8, if you think about it. So 8 and minus 3 is a positive 5 over 8. And so that right there represents the equation of the tangent line for this set of parametric, for this parametric curve, rather, for these parametric equations. So, as always, I hope this video was helpful, and remember, like and subscribe.